Well, of course, that's what a 2020 is.
I wouldn't show up. I missed my graduation. Oh my god. Yeah. I only have one B. Oh, weighted 4.67 on weighted 4.3.9.
For what?
My GPA.
GPA, huh?
Weighted is a 4.67.
Really?
You know, Mr. Young, just look it up.
What?
Just look up his GPA.
Oh, you guys ready?
Oh, no.
Oh, you haven't taken my class yet.
Oh.
Ooh, okay. All right. So, you guys ready yet? Okay, here we go. So, in this example, guys, we have f of x equals, we have the piecewise function, the square root of negative x, where x is less than 0, and the absolute value of x, where x is going to be greater than or equal to 0. Okay? Now, again, this is a piecewise function. And please remember when you guys are dealing with piecewise functions, that piecewise functions are basically just that. They are a function broken up into pieces. And you guys can see these two different pieces that we are dealing with, all right, are going to be two different functions, two different like expressions. We have the absolute value square root of negative x and the absolute value of x. So all I want you guys to do, just like I asked you guys to do before, is to just go ahead and graph each of these expressions separately. So for the square root of x, we know that the parent function looks something like this. But if we're going to go and reflect it, the negative inside the radical is reflecting about the y-axis. So the graph's going to look something like that. Would everybody agree with me at least on that? Yes? Yeah, I'm going to get to that in just a second. I'm just doing just the general graphs for right now. Then the next one is going to be the absolute value graph, which is going to be basically what we call the v graph, right? And you guys just did these, so these should be fairly new. The only difference is, yes, I am adding a negative reflection without having to talk over other students. OK, so now the next thing we want to do is apply our transformations. I'm sorry, we want to apply our restrictions on our domain, just like you guys did over there. Is that a question? During instruction? Oh, sure.
You just broke it down.
Huh?
I thought negative, like whenever there was a negative under the radical, it was I, you can't graph I.
No, that's if you're taking the square root of a negative number. We don't know what the negative number is. So for instance, like look at negative 1. The square root of minus negative 1 is 1.
So about positive 1.
Positive 1 wouldn't work. Do you see why there's no graph for positive 1?
Oh, okay.
Right? OK. So now what we need to do is restrict based on our domain. If you guys look at our functions, you guys can see that we have restrictions on our domain. So what we're going to do, guys, I really don't want to have to move my seating chart, but I think this class might be my one exception. Let's go ahead and focus here. So you guys, we look at our restrictions. You could say that we're only going to graph this one for x is less than 0. Now, we're good on that because, like we already discussed, the graph is already less than 0. So we're good. But to our point, though, x is less than 0. It's not including 0. So we have to include a open circle. For the absolute value graph, it says only graph this graph for when x is greater than or equal to 0. So all of these negative numbers, those are not a part of the domain because we restricted it. So all we're simply going to do is erase it. Now, this graph does have 0 included. So that's a closed dot. So let's think for a second, guys. If we take a closed dot and put it on top of an open dot, it's going to be now closed, correct? All we're doing with the piecewise functions is taking these two functions and marrying them together. So what our final graph is going to look like is going to be that graph, and then this graph. I don't need to include an open circle because that one enclosed it. So it looks something like that. Okay? Now, that's important because there's a couple things that just happened here. We now created a graph. And let's go and talk about the domain and range of this graph. When we go ahead and look at the domain, because hint, hint, wink, wink, it's going to be on an assessment. When we look at the domain, you guys can see that this graph continues to the left, and it's going to continue to the right. There's no reason for this graph not to continue in either direction. So we could say it's going from negative infinity to infinity. The range, however, you guys can see that there's a minimum value, right? The graph doesn't go below 0. So the range is going to be from 0 to infinity. But I'm not done. There's other things that we are going to ask of you when dealing with piecewise functions. Sometimes we're going to say, what is f of negative 1? What is f of 0? And what is f of 1? So we're going to have to evaluate the function. Now, this is really, really important stuff. And this is why I was really hesitant to let him go to the bathroom, because this stuff is going to be on the test. So you guys can just be happy that you get this instruction. And he's going to have to catch up. So remember at the beginning of the year, guys, I gave you guys like random functions. I said, like, hey, what's x squared plus 1? And I say, what is f of 2? And then to know if the function you just plugged in 2 into there, right? That's algebra 1 stuff, algebra 2, right? You guys are comfortable with, when you evaluate functions, you just plug it in for the x, right? OK, so piecewise functions, every single year, students get this wrong. Every single year, students get this wrong. So it's really, really important that you're focusing here. We need to evaluate the function f of x for negative 1. We have two functions. Should we pick one? Should we plug them into both? What do we do? The best way I can explain this is to look at the graph. If you want to find f of negative 1, you want to find the value of the function at negative 1. Well, what function did we graph at negative 1? The square root of negative x, right? So to evaluate my piecewise function, I'm only going to plug it in to the radical function. So it's minus a negative 1. Square root of 1 is just positive 1. Please understand, it makes absolutely no sense for me to plug negative 1 into the absolute value of x. Why? Because the absolute value of x is only for values that are greater than or equal to 0. So it doesn't even make sense to say, what's the value at negative 1? There is no value at negative 1. So don't plug negative 1 into that function. But let's move on to the next value, 0. So again, we look at 0. Well, which function was defined for 0? The radical or the absolute value? It was the absolute value. So plug in 0 into this absolute value function, which is just going to give you 0. All right? Now, again, it doesn't make sense to evaluate this function. It doesn't make sense to plug 0 in for there because the function has a hole at 0, right? So it doesn't even make sense. Then the last one is f of 1. And when we go ahead and graph f of 1, we're, again, looking at which function are we going to be evaluating with f of 1. You have to see its absolute value. So the absolute value of 1 is just equal to 1. Anybody have any questions on at least the first one? The warm-up, the salad, right? All right, let's get into some better stuff. Oh, it's only going to get better. All right, let's do a new function. Let's call this g of x. Let's do here. All right, new one. Let's go ahead and, again, just like I did here, why don't you guys go ahead and practice graphing them just for a quick second. And just go ahead and graph each one of these functions separately to make sure that you guys have the graphs identified so that you know what you're kind of doing for those. I'll give you guys a second to go ahead and do that. So, you guys done? What do you want to
Is the second one the same thing as that, but we just do that the -1 instead of the -2?
Sorry? Is the negative the same?
No, for the second one up there. Never mind.
That's kind of similar to the other graph. All right, so let's go ahead and graph the cubics. Cubic guy is going to be the XQ or the S curve graph. And then over here, we're dealing with the x squared. Sorry. Let's actually just apply the transformations to speed up along the process here. This is the x curve graph plus 1. That means the graph is being shifted up 1, right? So it's the S curve, because remember that point I told you guys for both these is at 0, 0. So I just shifted up 1. Looks like that. And then this is a quadratic that not only is this quadratic being reflected about the x-axis, it's also being shifted down 1. So it's kind of looking like what you guys kind of did in your warm-up. Okay? But now we got to look at the constraints. You see this constraint, this one is only greater than 0. So everything that's less than 0, that means all these negative numbers, those are not a part of the domain. And then, since 0 is also not, we need to create a hole. And then over here, you can see that this graph is only true for x values that are less than or equal to 0. So -1, -2, -3. All of those need to be on the graph. Anything positive, we're going to erase. But 0 is included on this graph. So now, again, all we do, guys, is just marry the two graphs. We put them together. OK? Cool? Now let's go ahead and go with the domain and range. Looks like the domain, guys, the domain is going to be, I forgot to mention the other one. The domain, you guys follow this graph. It's going all the way up, boom. And then you kind of have to jump. But you get to this one. Now we look at 0. Is 0 defined? Well, 0 is not defined here, but it's defined there, right? So at least we're good. 0 is still defined for the function. And then it just continues, and it looks like it's going to continue spanning. So the domain is still good. We're -infinity to infinity. The range, though, we have a little issue. Because as we're kind of following the graph from low to high, as you're following up, it looks like we get all the way up to -1, and then it stops, right? We can't go any further. So the range is going to be in parts. It's -infinity to -1. Actually, let's do the range over here. -infinity to -1. Is -1 included? Yes. So since -1 is included, we're going to bracket. And then we have to jump to the other function. And we start at 1, which is not included. So 1, we're going to use a parenthesis. It's not included. And then we're going to continue all the way up into infinity. OK? Now let's go and do our function values again. So let's do f of -1, f of 0, and f of 1. Now I will tell you guys, when I'm going to give you these problems, more likely than not, you're probably not going to have the graph to look at. So, or you don't necessarily need to have the graph to look at. I just like looking at the graph so it kind of makes intellectual sense. If we're looking to evaluate f of -1, it makes sense, guys. -1 is for this function. This function is for only values that are less than or equal to 0. So you're just going to plug -1 into there. Just make sure you guys use parentheses. It's -1 squared and then times a -1. And you can see that that value is going to equal -2. Yeah, it's -1 squared, which is +1. +1 times negative is going to be a -1. -1 minus a -1 is going to be -2. When you guys go to f of 0 now, so we have f of 0. Again, we look at which function is dealing with 0. Well, this one's defined. This one's undefined. Which one was this one again? Oh, yeah, this one's over here, which is that x squared. So you just plug 0 in for there. 0 squared is 0. 0 times a negative is always still 0. And then it's just going to equal -1. And then last but not least, we have f of 1. So again, we go into f of 1. 1's over here. That's that function. Over here, 1. That's good. 1 is greater than 0. Plug 1 in. 1 cubed is 1. 1 plus 1 is 2. Oh, crap. We ran out of time. All right. We got one more to go, and then I'll wrap it up with some. We're not going to have time for you guys to do that one problem I wanted to too. So, crap. All right, I got to do one of these. Sorry, I just got to like move on, or I got to do these quickly. So let's do. What have we not? Are we done? Yes.
Yeah.
Huh?
It's edgy.
Sure, sure. I'll name him.
Thank you.
You know, I'm just going to do this basic one. Okay. So we come up to a problem like this, and this one kind of looks a little interesting. This is different than, yes? So this one looks a little bit differently, all right? And I'm kind of missing on some examples that I would provide you guys. So if you guys would just remind me when you guys have that extra day, just to make sure I cover some of the other examples. I'm running out of time today because of that fire drill. So in this one, guys, still the same thing. Here's a nice little line, right? Y-intercept, 1, 2, 3, 4. Up 3, 1, 2, 3, over 1. Down 3, 1, 2, 3, to left 1. Looks like that. Now, this is important. This says this is true for all x. This is true for everything except what? X cannot equal 1. So where 1 was, we have to actually create a hole. Actually, yeah, well, I'll just do this one too. Now let's get into -2. What that really looks like is y equals, y equals -2. How do you really graph y equals -2? Yes?
Isn't it on the x-axis, it's just -2?
Well, here's the y-axis, -1, -2, right? And so, right, so you're just going to go a nice little horizontal line here.
I give credit to.
But when is this function, when is this true? It's only true for what? You don't need your phone.
There's no x.
Okay. Huh? There's no x in the equation. So, yeah, but guys, it's only true for when x is equal to 1. So here's x equals 1. That graph is only true right there. That's it. So x equals 1, y equals -2. So it's like a little hole right below it. Or it's a value point right below it. I don't know why I just erased that. What am I doing? So when you guys go ahead and graph this, it looks like 1, 2, 3, 4. 1, 2, 1, 2, 3 over 1. There's a hole right there. Oh, 1, 2, 3 over 1. OK, so there's the hole. But at -2, there's the solid point right there. So it kind of looks a little odd, right? It's basically a function with a hole in it. And then there's the other value, which is like your dot, what it equals. OK? So I'm going to get this and explain, because these are going to be our different types of continuity that I explained. So I'm just going to end my recording, and then I'll get into my different types of continuity. But I just know that I'm going to be interrupted. So I would make sure you guys listen to this, because this is actually something very, very important.